So this question is one of the fairly standard ones that tend to come up in a Nat 5 paper. It's all about simultaneous equations. Now, this sort of question, they'll give you a scenario. There will be a couple of things in the scenario related to each other. So in this case, bags of gravel and cement. They'll give you a solution, if you like. So in this case, it's talking about the weight of them. You'll have to come up with a couple of different equations and solve them. I mean, the reason being, if you think about it, when you've got an equation, if you've got one thing in it, you're able to solve it. As soon as you put more than one thing into an equation, you have to have more than one equation to be able to solve it. Now, in this case, you've got two things, your gravel and your cement, and you've got to be able to solve for both of them, so you need two equations. Now, this sort of question tends to have the same format. Here's your first bit of information, write down an equation. Here's your second bit of information, write down an equation, figure it out. So in this first bit, you've got 7 bags of cement, 3 bags of gravel, total weight is 215 kilos. Write down an equation to illustrate this information. Now when you're writing down the equation, some people tend to stick to x and y because it's the two variables you know. A lot of people think of the context. So this one's 7 bags of cement, 3 bags of gravel. So they'd write it as 7c plus 3g. So your c represents your cement, your g represents your gravel. We know that the combination of the two of them is 215 kilos, so 7c plus 3g is equal to 215. There's our first equation right there. Second one, we've got 5 bags of cement, 4 of gravel, 200 kilos, so what we can then say is fine. So I've got 5 bags of cement, and I've got 4 bags of gravel, so 5c plus 4g, that's going to equal 200 kilograms. So there we go, I've got my second equation there. Now it wants the weight of 1 bag of cement and 1 bag of gravel. So I need to figure out what C equals and what G equals. To do that, I set up my system of simultaneous equations, I solve for one variable, then I solve for the other. So I'd set them up, 7C plus 3G equals 215. Second equation would be 5C plus 4G equals 200. And now I solve for one of the variables. Now it doesn't matter which of the ones you solve for. Look for which one would be the easiest. So in this one, I would probably pick the G, because to do that, I'd have to multiply the top by 4, multiply the second equation by 3, and I'd have the same coefficient in front of G, and I could solve it that way. If I chose to get rid of the C, what I'd do is I'd multiply the top by 5, and I'd multiply the bottom by 7, eliminate the C variable now because they both have the same coefficient, and then work it through. So if I stick with the getting rid of the G, multiply everything in this equation by 4, so I get 28C plus 12G equals 4 of these, so equals 860. Multiply this one by 3, I get 15C plus 12G equals 600. Now, to get rid of the G, if they've got the same sign, subtract one equation from the other. If they've got a different sign, we add them. So they're both plus, so if I do the top equation, take away the bottom equation, I'll eliminate the G, I can solve for the C, and then find my G based on that. So if I take the top equation and subtract the bottom, 28C minus 15C, I get 13C. The 12Y take away 12Y is nothing, and that equals 860, take away 600, so I get 260. So I've got 13C is equal to 260. If I work that through, divide both sides by 13, I get that C is equal to 20. Now that I've got that C is equal to 20, I can go back, substitute it into any of these 4 equations, and solve for the G. I'm going to take this top equation here, so I could then do, right, so 7C, so 7 times 20, plus 3G, equals 215. So 720 is 140, so 140 plus 3G equals 215. Stick the 140 across there, subtract it. What I end up getting is that 3G is equal to 215, take away 140, which gives me 75. So if 3G is 75, I know that G is equal to 25. Great, so I've solved for C and I've solved for G. That is not the answer though. We've got the letters, we've solved for the two variables, great. We have to now put it back into context. This step of communicating your answer in the context of the question is one of the most vital that we can come across. Now I know C represents cement and I know G represents gravel. We have to imagine that whoever reads this question doesn't. So what we then have to say is that 1 bag of cement equals, well, it's 20 here, so it equals 20 kilograms. And then 1 bag of gravel we know that that equals 25 kilograms. So there you go. Now we've communicated the answer. Now we've told them what we need to tell them and put it back into the context. That is us done it now. We have to make sure we do that. That is a vital step when working these sorts of questions through. We have to make sure we clearly communicate the final answer and that we are able to tell them exactly what they want us to tell them. In this case, the weight of 1 bag of cement and the weight of 1 bag of gravel. This kind of question here, 5-mark question, maybe a 6-marker, depending on how you would have to do it. You get 1 for each of the 2 equations. So you get 1 for A and you get 1 for B. You then get, in this case, 4 marks for the second one. First thing would be to scale it properly. Second thing is solving it for one variable, then solving it for the other variable, and then communicating your answer. If you didn't have this step here, so if it was just a standard, here's 2 equations, solve it, you wouldn't get a 4th mark at this stage. So just be aware that that stage is a vital one and it could actually cost you marks if you don't do it properly.